Hello to you, my esteemed colleagues and friends. My name is Steve Anderson. I'd like to talk to you briefly about architecture. I was preparing some content about 3D printing, and I found myself talking about architecture, and it really is a rich subject and a good analogy to discuss architecture, that is 3D printing. Now, what do I mean by architecture? I'm referring specifically to the architecture of systems, electronic systems, end-to-end systems where there's a user on one end and something on the other end. The systems that will become commonplace, the systems that already are commonplace, and the systems that must be introduced. I found myself comparing and contrasting some architectural ideas, and I found them to be general enough to present to an audience such as yourself. I hope that what I share is helpful and might spark some conversations between yourself and your colleagues. I sincerely wish you all the best of luck. Thank you. Alright, so I've prepared this list here. These are properties that an architecture can have. Normally, I would explain a system by explaining what it is. When you enter a field as a novice, you start with something and you figure out what it really is. But here now, I'm explaining what I wanted, which led me to what I chose. I've built stepper motor drivers, PID-controlled systems, internet-controlled systems, from metal to software. I've studied the kinematics and the theory of linear systems, etc. in school. So I knew what I was getting into, and I'm just late to the party. And what I found was that with the Marlin system or with a stock system or many commercial systems, it wasn't going to be what I wanted. I started searching, and Klipper and its associated stack revealed itself. One more note, I'm a big fan of Richard Stallman, and forget the whole free software thing. It's about me being in control of my machine. I don't like SolidWorks being in control of my designs. I don't like the slicer being extremely complicated to the point where you almost need a PhD in math to talk about it. I don't like the slicer being that middleman gating access from my designs to my machine. Now, of course, it's a tall order to ask for an alternative, but that's how I think of things. It's not the tool, it's not the software, it's the architecture, it's the stack. So let me go through these bullet points and explain sort of what they mean to me, or how and why Klipper covers all of these bases. Now, of course, Klipper is not the only choice, and Klipper itself doesn't inherently satisfy these requirements. It's just a choice. Anyway, so first off, remote control. With a Marlin-based system, you do not have remote control. You have manual control. Now, this might not be strictly accurate, but just hear me out. You manually have to load an SD card with G-codes, and you manually have to command the printer through the touchscreen interface. With a Klipper system, basically everything that the printer does, aside from maybe fail-safes or booting up, everything is basically controlled by the host. The printer is just sitting there waiting for commands, and that inherently lends itself to a remote control architecture, because it can't even do one thing outside of the host's control, which in a sense renders the touch screen obsolete. The only thing you should be able to do manually is hit the panic button and shut it off. Okay, so faster. Faster to me means iterating faster, and iterating means making mistakes. I want to make more mistakes faster. And I found that in most cases, this trumps having application domain experience, particularly when the solution domain primitives, i.e. G-code in this case, are mathematical and algebraic. The SD card having G-codes on it was immediately just the first time I even heard of that. It just sounded like nonsense to me. Even before my first print ever, I knew that I would be unwilling to adopt this workflow. Loading SD cards and sneaker netting them to a printer causes massive friction, especially at the beginning when I barely know what's going on. Now that may sound unreasonable, but think of the other side. Imagine being able to release your designs, say in SolidWorks or Fusion 360, release your designs, and then immediately after, perhaps even automatically, your designs could be sliced up into G-codes and executed onto a printer. Okay, safety. Safety is a big thing for me. I had a boss once, I'll never forget it. He used to say, "Safety last." He in fact told me that he would rather have me die of electrocution in a violent explosion than for one of his expensive pieces of equipment to be damaged. And he said that truthfully, not to be condescending or a jerk. It was actually true in terms of the numbers, the bottom line, and this was very eye-opening to me. But for me, safety is first. And with a 3D printer or any machine, that means that I will never leave one unattended, especially if I cannot be fully in control of it. going back to remote control, if I have full remote control, then me not being there is basically the same thing as me being there. It's kind of interesting, this parallel between safety and remote control. In my opinion, they go hand in hand. Okay, extendable and bidirectional. I also don't like the whole stack of, it's kind of like an opposite stack where the design in your CAD gets exported as an STL, which then gets sliced by a slicer and then emits G-code. It's sort of a top-down or design-first workflow. I don't like that particularly because there's no full circle, there's no loop, and the tools, which are very expensive, and the people licensed to use them become a gateway to progress, even with the best of intentions. I want top-down, bottom-up, middle away, and end-to-end full circle out. I've been experimenting with this sort of G-code upstack, which is very interesting, like for example using the Hilbert space filling curve to infill a solid. Having as much fun as I'm having would not be possible with this traditional design-first workflow. And now going into the bidirectional facet of architecture, when the printer is always engaged with the host, that allows for certain abstractions and parameterization to happen across that communication link. Whereas contrast that with a system where you basically have to prepare the G-codes for a job entirely in advance. Well, what is a job, and what really did you prepare? It sounds silly to say, but I think you know what I'm talking about. At the end of the day, you have an idle printer, and it needs to start doing something. I'm sure you've run into times where you wanted that printer to do something, but all you have is a bunch of G-code files. What even is a file anyway? Sometimes it might seem very simple what you want the printer to do, but it's actually not. That's why breaking down operations and communication into primitives that go across a bidirectional link in an extendable manner, extendable meaning G-codes, G-code macros, and that sort of meta kind of stuff where the host and the system as a whole can intervene at the finest level of granularity, as well as being able to compose jobs at arbitrarily high levels of granularity. Okay, so lazy and just in time. These are topics of computer science where, really honestly, I don't know what I'm talking about, but I can appreciate their power. Laziness, for example, being able to render designs or slices of a slicer, rendering that into G-code later, or perhaps on the printer host instead of your design workstation, is powerful. One application of this could be if you want to store G-codes in a key value storage, such as Google Firestore, where the maximum document limit is 1 megabyte. Well, I bet you most of your G-codes that you print are more than 1 megabyte. G-code files are almost entirely wasted space in terms of information entropy or Shannon entropy. What if you could sort of evaluate jobs, meta jobs, job templates, whatever you want to call it, on the fly as they get printed, or even parameterize the print as it's happening to compensate for whatever, like maybe make a little embossing of the current time and date somewhere. Think of it as your design can be just the design. It's the representation or the specification of what should be rendered. It doesn't have to be the rendering itself. Laziness is very powerful because you can choose to be lazy. Do it later or now. You could even do it somewhere else later. It again kind of relates to all these things. And so this is sort of what I had in my head and as to how I wanted to use my 3D printer. And so asking around my friends, looking on the internet, it became very obvious that my printer's firmware, and it's funny how it kind of all rests on the firmware, my printer needed to be running Klipper firmware controlled by a Linux host. Well, that's all for now. I hope that helps, and thank you very much.